3 of the Week 7 Learning Guide for College Algebra. If you missed parts 1 or 2, I'll be sure and link them below in the description. That way you can access them. And if this is the first time you're seeing my face, hi, my name is Dr. Marissa May. I'm on a mission to help students feel confident in their math class. And to do that, I'm providing resources like these videos and this learning guide to help you be successful in your class. So if you have questions or comments or other resources you would like to see, please leave them below in the comments. I would love the opportunity to help in any way that I can. If you would like a hard copy of the learning guide here, I've linked it also in the description. That way you can download it and follow right along. Well, let's jump right in. In week 7, we've been focusing on logarithms. And I'll be honest with you, as I said in one of my other videos, I don't think in logarithms. So I have to be very careful and very intentional with using the properties and my tools, such as my calculator, to make sure that I understand. So for our purposes, I'm going to be using Desmos Graphing Calculator. I will link it below. That way you can use it. If you're using the TIA 83 or 84, it totally can do everything that we're doing here. I'm just using Desmos because it's free and available to everyone. So without further ado, let's jump right in. With number 1, we are going to use our calculator here in just a minute, but before I do that, I want to do a little setup. We're asked to evaluate the log base 9 of 13. Now, understand your calculator only understands 2 bases for logarithms. It understands base 10 and it understands base e, which we talked about in the previous video with the natural log. I'm going to use base 10, but in order to get my calculator to give me the value for this, I'm going to have to do what's called a change of base. Now, in order to do a change of base, we are going to change the bases here to a 10. And to do that, I'm going to create a fraction. So I'm going to do log base 10, which remember, I don't have to write, of 13. Notice that's the number inside. And then I have to divide that by log base 10 of the original base, which is a 9 there. Now, let me switch our view so that you can see the Desmos graphing calculator and see how I'm going to type this in. I'm going to type in the log, and I have to put parentheses around the 13. That's just the way the calculator understands it. And then divide by, and again, you've got to do log and put parentheses around the 9. When you use the parentheses, the calculator will understand that log that I just typed as the logarithm, okay? So that's one way to get your calculator to tell you a value is to use a change of base formula. Okay, let's go back to our learning guide then and look at problem number 2. We're asked to solve the logarithm, and I want you to see I'm actually going to use 2 methods. The first method I'm going to use when there's a log and there's a single number. There's logs, but it's equal to a single number. Okay. The second method I'm going to use is on problem number 4. Do you see how everything has a log with it? I'm going to use a different method for that. So you'll need to distinguish between the 2 methods based on, does everything have a log or does everything but 1 have a log? Okay, when everything but 1 has a log, we want to condense down to 1 logarithm. I have that. Then I'm going to convert it to an exponential. So we did this in the part 1 video. So if you need to go back and kind of refresh your memory on how to do that, you can definitely do this in part 1. We start with the base and we go to the exponent. So that's 2 and it equals what's inside. That's x. So x equals 81. Again, remember, I said I don't think in logarithms. So my whole goal is to convert this to an exponential so that the logarithm is gone, right? And I can deal with exponents. Now let's look at problem number 3, because I'm going to use a similar tactic. The difference is, the reason I use a similar tactic is because there's a single number that it doesn't have a logarithm with it. But what I have to do is condense this down first before. So I've got to get rid of this 2 here. I'm going to divide both sides by 2 so that I get log base 2 of x plus log base 2 of 5 equals 8. Okay, now remember, when we see addition, we can rewrite that as multiplication. Oh, but that's not equal to 8. That's equal to 4. Okay, so this becomes log base 2 of x times 5, which is 5x, and that equals 4. Now that I have a single logarithm equal to a number, I'm going to convert to an exponential. So it becomes 2 to the 4th equals what's inside, and that's 5x. So 2 to the 4th is 16. 16 equals 5x. Then you can divide both sides by 5, and you'll get x equals 16 fifths or 3.2. Either one will work here. Now, but the whole idea, remember, we got to condense one side down to a single logarithm. Then we can convert to an exponential. Okay. Now, the other strategy I'm going to use is on number 4, and this is because everything has a logarithm with it. Okay. So again, the idea is to get a single logarithm equal to a single logarithm. To do that, on the left, we're going to have to condense. So I'm going to take my coefficients and make them exponents. So I got log base 5 of 2 to the 3rd plus log base 5 of x equals log base 5 of 24. Okay, now we see addition. I know that means I can rewrite this as multiplication. So now I've got log base 5 of 2 to the 3rd is 8 times x equals log base 5 of 24. Now, once you have condensed down to 1 log equals 1 log, you can drop the logs. So that becomes 8x equals 24, and you can divide by 8, so x equals 3. So 2 strategies to solve. Please notice the difference, okay? We used this strategy, converting it to an exponential, when we had all logs, but one number was by itself and didn't have a log. We drop the logs when we have everything has a log with it. We condense down to 1 log equals 1 log. Then you can drop the logs and solve the equation. So I hope this helps you with the logarithmic equations. As always, feel free to leave a comment or a question. I would be honored to help. Bye for now.